Hi, welcome back, and today it's a repair day, and it's going to be a pretty simple repair, and one that might be of use to you if you've got any kids and they have a Scalextric track. Okay, and this is from my first Scalextric. Okay, it was brought in by someone that I work with, Tim, and yeah, his kid was playing it and they had it all set up, and suddenly there's a load of smoke coming out of this part. Okay, the actual power section for the track, and his toy stopped working and his kid wasn't particularly happy, and they brought it in and asked me, yep, can I take a look at it, see if I can fix it? So I thought, well, not a problem. If it's got smoke coming out of it, it's going to be pretty obvious what the damage is going to be, and there's not really going to be that much in these things, okay, to test and go wrong. So it's going to be quite a simple fix. It's about 16 volts input, okay, and it's got a little wiggly line next to it, so it says AC. I'm not really, but I've been searching around, none of these actually use AC, they're all DC supplies nowadays. I don't know why. That says 16, and controllers use 12 volts controllers, and you know, yeah, right, okay, so it's going to regulate it down to that 16 or whatever it is plugged in there, down to about 12 volts, and it's probably just, it's just a variable resistor on the control, so it just control the current to the tracks on here. So let's take it apart and take a look. Might be interesting, might be quite boring. Okay, let's see what's wrong with it. Now on the rear, you can see that there's 4 screws, little crossheads. Right, let's get some tools. I haven't got any on my desk. I'll be back in a moment. Okay, so here we are. Let's start unscrewing it. I've just got me a National Instruments freebie, a flathead and a crosshead screwdriver here. Nothing particularly special. Multimeter to do some tests on the components, and yeah, here we go. So let's take this sucker apart. Okay, let's see what's inside this bit of track, how it all goes together. As it all comes. Okay, all the screws out, that should just come off, it does. Okay, there's the board. Okay, it doesn't look like that there's a great deal on there. Okay, power in, a couple of jacks for the output. Nothing special, a few flying leads off to the tracks. Looks like 2 positives for the 2 positives, 1 ground, obviously 2 controllers, and that's all split down here. Okay, let's see if we can get this is tight in here. Now, what we've got on the opposite side, let's have a look. Right, yeah, we've got a couple of looks like 3mm jacks, 3.5mm jacks there. It's down to DC power jack. That's the culprit. Okay, if you can see that, what used to be a looks like a ceramic disc capacitor is now a black and charred mess. So this is the thing that was actually smoking. Actually, that is so smoking it's crumbled apart in my fingers when I just touched that. So there it is, in pieces. Okay, you can see that. So that's what's got to be replaced. Doesn't look like much. You got some diode protection. What it looks like, yeah. If you follow the tracks back, it looks like there's some diode protection on the input stopping the reverse. Same thing, diode protection on the outputs in case you short the tracks. A few smoothing caps just to smooth it off. Just a LED and a resistor just to say whether you've got the power on. Nothing particularly wonderful there. Okay, it's just basically splitting that. It's just dropping that 16 volts down to about 12 volts and splitting it to the outputs, and then it comes back from your your variable resistors, what are in your controls, down to your tracks to vary the speed of your cars. Now then, looking at these caps, across the output we've got some 0.22, these ones here, 0.22 microfarad caps. These discs, 0.1 microfarads just across the diodes, just for a bit of smoothing. 1N4002 standard diode, yeah, nothing special. This one, cap ceramic disc, that's gone. Don't know what value it's meant to be, so I'm going to hazard a guess. So for this repair, because it's across the supply, you know, anything above, well, it's 16 volt, be across it, I don't know, any diode up to, I don't know, above that will be fine, power rated wise. If it's a ceramic disc, probably about 50 volt ceramic disc. There 0.4s, there 0.22s, it's across the primary, so I'll whack in the 1 microfarad ceramic. I got those knocking about, and yeah, hand it back over. If it goes, it goes. I know it was the wrong value. If it works, then brilliant. So let's replace that, and yeah, you can actually see the scorching up here on the plastic. What should I do next? Let's just check over the other components, see if none of these have been took out. Let's have a look. Let's switch it to our diode measurement first. I'll set this up here so you can actually see my meter. Bloody hell. Right, here we go. You can just about see my meter there. I've got it on diode test. We'll check out these diodes and we'll check out the caps. So diodes first. Forward bias, yeah, about 0.6. Reverse, overload. This one, that one is, yeah, 0.5, 0.6. Fine. Reverse, fine. You can actually see the. Don't have to check the LED. Look at that. I don't know if you can see that on here, but it's actually flashing up when I'm doing my diode checks across some of these diodes. Okay. Yeah. It's fine. Yeah. It's okay. Not a problem. And let's bend that forward so you can actually see that LED. There we go. Lighting up. You can just see that there. Forward, reverse. Yeah, fine. Whatever. Might as well check over the cap. So I switch this to cap. Check these. Yeah. 0.22s. Yeah, fine. These ones are in parallel with the cap, so they're not really going to give an accurate reading, but we should be able to get something. I'm not really going to get anything unless we pull them out of the board. But yeah, it's reasonable. Nothing particularly special there, they all seem consistent. So it looks like it's just that one cap that's gone, so I'll swap it over and we'll plug it back together. Yeah. Alright, back again, just swap that component out. Okay, there's the replacement one. Okay, you can just do it up that way, make it easier. Okay, so there's the replacement. That just replaced that black and charred mess, and it's not a ceramic disc one, okay, but it's still a ceramic. It's not going to be that make that much difference, okay. Especially something like this is really simple fix. Don't have to worry about polarity. Don't have to, you know. That's one that I had knocking about. It's 1 microfarad. This 50 volter. It's more than enough. So let's whack it all back together, and yeah, job done. And hopefully I will be making some children happy in the process that their toy's working again. Now I don't know why that cap would have gone. Hopefully it wasn't the actual power supply that was plugged into this. I have lost a screw. Oh no, I haven't. There it is. If it was the supply, then you might be in trouble. If it wasn't, then it should all be working. Okay, hopefully it was just one-off thing. Oh bugger! LED's not through. That's where I bent that LED over a little bit. Just unscrew this again. Pop this all that together. Bend that back. Make sure it goes into the blinking hole like that. There we go. Done. Slap it back together. Job done. That was a simple, easy one. Like I said before in my videos, I think on the screen repair one and the Kindle one and the solder one, when I was showing you how to solder, I mentioned that sometimes repairing things can be really straightforward. You don't have to go out and spend tons of money on something new or it's identical replacement, anything like that. I had that component knocking about, it didn't cost me anything to do, and hopefully that'll be working again. And if I had to go out and buy a new cap, buy it from Macklin's, well, you're going to pay what, 50p, 60p for one. Go to Radio Shack, you can pick them up for what, 20p each, less than that if you want to buy a couple of them. It's not exactly breaking the bank. Even if you don't manage to get it fixed, you learn something, and yeah, always useful. Give it a go. Sometimes they're really simple fixes like that. Anyway, one last thing before I go. Okay, you know what I mentioned at the beginning that it looks like it could be on the front of the unit. Okay, it had a 16-volt squiggly line, V squiggly line. Could have been AC. Okay, obviously it wasn't, because that cap which I replaced was across the supply. If it was an AC, that would have been a direct short to ground. Okay, as we all know, capacitors pass AC. Okay, so yeah, so obviously there's not an AC supply. Just in case you're everyone out there saying, hold on a minute, you said that's AC, it can't be AC. But yeah, not an AC supply, it's actually in fact a DC supply. And that may have been the cause of it, so I'll have to ask Tim whether or not he's plugged in the right supply for it, or whether it's one that he found on the shelf somewhere. Yeah, anyways, catch you next time.